So welcome to this talk on predicting season outcomes for the NBA. My name is Lambrix, and this is work together with our student Teno Gonzalez de Santos and my colleagues Chunyan, Wang and Niklas Carlsson. I will give a short motivation, then talk about methods and results, and finally conclude with a conclusion. So in this paper, we look at prediction of game and season outcomes. And this is interesting for the entertainment industry, which includes the betting companies. Much money is spent every year on betting on game and season outcomes, and thus being able to predict the results of individual games or the league is important. Also for clubs, understanding the critical factors of winning games and championships is important for creating a competitive team and for implementing winning strategies. And this paper focuses on such predictions for the NBA. So what we want to achieve in the end is a way to predict to which stage of the playoffs a team will reach. After the regular season, 16 teams will qualify for the playoffs. The playoff stages are first round, conference semifinal, conference final, NBA final, and NBA champion. As you can see, the teams are divided in two conferences, here in blue and in red. And the winners of the two conferences play the NBA final. So the season outcome prediction is done by developing first a method for game outcome prediction, and then using that method for simulating each season 10,000 times. For the regular season, you will use the actual schedule, and for the playoffs, we continue based on the rankings after the simulated season. Most of our data is taken from Basketball Reference, but for comparison purposes, we also downloaded ELO data, and that we got from 538. We looked at 10 NBA seasons from 2008-9 to the 2017-18 seasons. Now, as the second part of our method is a season simulation, it only makes sense to use data that can be computed after each game simulation. So therefore, for instance, we do not use any box score data for particular players in particular games. We also decided to use data from current season as well as from previous seasons. Of course, not from future seasons. And this led us to the following selection of data. First, we have box score data. So from the box score of a game, we used information about the home team, because there may be a home team advantage, about the season stage. For the regular season, we looked at the number of games played up to now, wins and losses up to now, and also similarly for the playoffs. Further, we checked whether the last game, the last home game, and the last away game was won. We also collect information about the recent performance of a team in the last 3, 8, and 15 games, as well as the home games and the away games. And we check these sequences of home and away games because very often the teams have a road tour or they play many games in the sequence at home. Finally, we also look at back-to-back games because it's known that the performance of players usually decreases when playing consecutive games in a short time period. Then we looked at team performance from the previous season, and we gathered data about which stage they reached and how they did in the regular season. We also collected an offensive rating in terms of points scored per 100 possessions and a defensive rating in terms of points allowed per 100 possessions. And we also gathered the 4-factor metrics. For the offense 4 factors, we have the effective field goals percentage, which is just for 3-pointers, the turnovers committed per 100 plays, the percentage of available offensive rebounds, and the free throws per field goal attempts. And we have similar defense 4 factors. We also looked at individual players because they have an impact on the team performance. And this is particularly true in sports like basketball, where there are only 5 players per team that are on the court at each moment in time. And also the top players often play the majority of the game. So therefore we collected a summary statistic of the staying, the signed, and the leaving players. And this statistic estimates the number of wins that was contributed by a player per 48 minutes. And 48 minutes being the time of a regular game without overtime. The total salary is also important because it has an impact on the quality of the players that the team can attract. The total salary versus salary cap may be a factor because teams have to pay a luxury tax if they pay their players over the salary limit. And in many teams, the focus on spending for salaries is on the top 2 or top 3 players, which are often called the big 2 or the big 3. And therefore, we check the percentage that the team spends on the top 2, top 3, and top 5 players. And finally, we collected data on the draft picks, where talented new players can be brought into the teams. The draft consists of 2 rounds. And we collected data on which places in the draft the teams could pick their new players for the last season, the last 3 seasons, and the last 5 seasons. For the game outcome prediction, we used 4 algorithms: logistic regression, linear support vector machines, multi-layer perceptron, and random forest. We did hyperparameter tuning for each of those, and we performed feature selection and selected the features that gave the best results. And then we compared these algorithms with respect to their accuracy. And the best version of logistic regression gave us 68.58%. For linear support vector machines, we got 68.18. Multi-layer perceptron, 68.85. And random forest gave us the best accuracy of 69.88%. And this is then also the algorithm that we are going to use in the coming steps. So for this random forest, we had looked at the top 50 features. The most relevant feature was the performance of the staying players during the previous season. Also important, but a bit less, was whether the team was a home team. So there is a home team advantage according to this. And the rest of the top 50 most important features have relatively similar values and quite a bit lower than the first 2. And among these, we have wins and losses in the current and the previous seasons. For the last games, it's more important to look at the last 15 games than it was to look at last 3 and 8. There are also some features related to the total salary of the team, the percentage over the salary cap, and the salary of the top 2 and top 3 players. So here we get the big 2 and the big 3. And then also factors regarding the team performance, both offensive and defensive, from the previous years, and regarding the performance of the leaving and signed players were on this top 50 list. So we then simulated 10 seasons. We trained the game outcome model on the previous seasons. We used the actual schedule for the regular season and then updated the current season features after every simulated game. We didn't use any data for future seasons, and we performed 10,000 simulations. And then we received a table like this, which for every team and every stage, we have a prediction score. And when we evaluate this, we will say that our prediction for the NBA champion is correct if the team with the highest prediction score actually became the champion. For NBA finals, we will say that we have a correct prediction if the team has one of the 2 highest prediction scores and was in the NBA finals. And similarly, For the conference finals, we look at the 4 highest prediction scores. For the conference semifinal, at the 8 highest, and for the first round, the 16 highest scores. So what we can see is that our method predicts 129 out of 160 possible first rounds correct, 58 out of 80 conference semifinals, 24 out of 40 conference finals, 12 out of 20 NBA finals, and 5 out of 10 NBA champions for all the 10 seasons. So is this any good? Well, we compare this to the ELO ratings from the beginning of the season. And we notice, this is the second column, and we notice that we outperform the ELO ratings in every case. We also checked with respect to the preseason odds, and this is in the last column because we only had the preseason odds for the NBA champions. And we see that we have the same results as the preseason odds of the betting companies, except for the 2008-2009 season, where the betting company actually had 2 possibilities for the champion, both with the same odds. So to conclude, we have a game outcome prediction that reached a mean accuracy of 69.88%. And we have a season outcome prediction, which is equally successful in picking the champion as odds makers, and it outperforms ELO for all playoff rounds. Thank you for your attention. If are there any questions, I'll be happy to take them.